And for today, we are going to start with chapter 7. I will leave chapter 6 till I introduce rotational motion. Then today we will start with chapter 7. Okay, and some of the vocabulary that we are going to talk about: work, energy, I will say kinetic, energy, potential energy, and we will figure another method of problem solving or doing solutions to acceleration or velocities. Now the first thing is we want to introduce the first quantity, work. Work is defined as a force acting over a distance. If there is no motion, there is no work. Now, also, something very important is the angle between the force and displacement. These here are really vectors. Okay, when we multiply them, their magnitude is f d cosine theta. This one here you don't have to worry about. This is beyond the scope of the class. But work is f d cosine theta. Now what is new here, that this theta is the angle between the force and the displacement. It has nothing to do with the axis. Okay, and for example here, I will show you several examples just to show you how we are going to calculate. For example, I have an object that is on a level table, and there is a force that is 20 newtons acting, and it was moving the object for a total displacement of 2 meters. Then work here is gonna be the force times the displacement, which is 20 newtons, times 2 meters, and that is gonna be 40 newtons meters. One of the things that we need to know, that work is a scalar quantity. Scalar quantity, it doesn't have a direction. Now, a Newton meter is 1 unit, and we can also say a Newton meters equals joules, okay? And here, when you have the force in the direction of the displacement, this is the maximum we're gonna get. Now, I can have another situation where I have the force acting at an angle which is 60, okay? And it is the same force, which was 20, and it was able to move the object 2 meters. Okay, I need to find what is the direction for the displacement. This is D, and the angle between them is 60. Then it's gonna be FD cosine 60. Yeah, here it is cosine 0, and cosine 0 is 1. Here it is 20 times 2 times cosine 60, which is 1/2. Then this is gonna be making it 20 joules. then you can see that the work is actually, with increasing the angle, it is decreasing. Number 3, there is another case which is very interesting, which is when I have, this is the displacement and this is the force. Here, it's not lifting an object, it is carrying an object and moving horizontally. Okay, then you are carrying a bag or your backpack and you are moving horizontally, and as a result, your object was moving, let's say, 2 meters to the right. Here we will say work is FD cosine 90 and cosine 9 is 0. Then in this case here, we will not get any work. Then the work done in this case is going to be the case where we are going to have 0 work. Another case which is really also interesting and we need to know about it, it is when I have, this is my object moving to the right, all right? Then the displacement, which is the red vector here, D is 2 meters. But the force here, it is to the left, like force of friction, and it is, let's say, 20. Okay, in this case, the work done is going to be again FD cosine theta, and that is going to be 20 newtons times 2 meters cosine 180. Cosine 180 negative 1, then this is negative 40 joules. Then the work of friction, it is negative. Okay, now whenever I'm gonna do kind of work, then I will say the work is going to be always adding. If I'm doing work on the system, the work is gonna add energy to the system. Now, in all the cases here, I assumed that the force is constant throughout the process. Now, what if the force is not constant? We're gonna have it from the graph, the relation between the force and the displacement. Whatever it was, you're going to find that the work will equal the area under the graph. Then you're gonna calculate the area under the graph, and in order to calculate the area under the graph, you will do maybe divide this into triangles and rectangles and find what is the area under the curve. And this is when the force is not actually, it's not constant. Also, there are occasions when you have more than one force acting on the object. And in this case, you're going to say work net or work total is work 1 plus work 2 plus work 3 plus work 4, kind of adding all the works done by all the forces. Now we can say that work total equal to force, the net force, times D. That net force, it is MA times D, the displacement. I can remove the A and put V final minus V initial divided by time times D. What I can do, no, this is not gonna be beneficial for me. Let me do one more thing. Okay, let me have show you first why I'm gonna do this. Okay, I have the equation that V final squared equals V initial squared plus 2AD. Okay, from that I can say that A is V final squared minus V initial squared divided by 2D. I can take this and put it here. Put it here. Then I will say work total should equals M. A, we're gonna remove it and put this expression times D. And then after that, what I can do is I can cancel the D from here. I can say work total equals 1/2 mv final squared minus 1/2 mv initial squared. This equation, it's very important, and we call it the work energy theorem. And we can write it as this: change in kinetic energy. Then here we added a new quantity, we call it K, equal 1/2 times V squared, and this is, we call it kinetic energy. Kinetic means motion. Sorry. Okay, which means this is the energy of motion. Okay. Let me do one example here. Just to show you how we're gonna do all the concepts here. Let's assume here that you push on the 30 kilogram package with a constant force that is 120 newtons through a distance of 0.8 meters, and that there is an opposing frictional force that equals 5 newtons. We can use this example to calculate the final velocity of this package if it starts from 0. Okay, then here what I will do is I need to know what first determine the forces. Okay, then here I have that package. I have that driving force F. I have force of friction. I have normal. I have mg. These are the forces. Now, that package has been moving for D. That D, this is the direction of D, and that D is 0.8, I believe. Yes, 0.8 meters. Okay, first I need to find W total because it has the work of the force plus the work of the normal plus the work of mg plus the work of friction. Now, work of normal and work of mg equals 0. The reason is this is normal d 90 degrees and this is mgd 90 degrees again. Then both of them they not gonna they not gonna do any work. This is 0 and this one is 0. Work done by the force is gonna be force d cosine 0, which is 1, and then is gonna be the force, which is the 120 times the 0.8 meters, and that is going to be the is gonna be, let me because I'm gonna tell you here there are two approaches. Then here 120 times 0.8, 96 joules, and work done by friction is force of frictions times d cosine 180, which is the force of friction is 5, and this is 0.8 cosine 180, and cosine 180 is -1. Then 0.8 times 5, it is -4 joules. Now the work net is going to be adding both, and it's going to be 96 joules minus 4 joules, which is going to be 92 joules. There is another approach, which is finding the net or the resultant force and then calculate the work, but I will prefer this method. Okay, now also I know that the work total equals 1/2 mv final squared minus v initial squared. Now, since my initial was 0, my total here is 92, and the mass is 30 kilograms. Then I will say, 92 times 2 divided by 30, and then take the square root. This is the V final, which is going to be the 2.4 8 meters per second. This is how I'm gonna calculate that velocity. I'm gonna stop here so that my videos, they're gonna be short, easier.